If you're watching the last video, you saw this happen. Yeah, let's sort that out. Welcome back to the workshop, and welcome to this ongoing series to try and improve this drill press by adding more space underneath the chuck and adding motorised knee. So in the last video we achieved at least one of those, so we cropped the sides and the back down and now we've got a lot more travel. I'm pretty happy with that. But we clearly fell short on the lifting capacity of this system, so let's get into that. So double check the spec of that motor. It's a pretty old one I had lying around in the box from many years ago, and it's a 1.8 Newton meter holding torque. Now that runs through a pulley ratio which effectively gives out another 50%, so that comes in about 2.7. Now that's holding torque, and we all know that as soon as that starts moving that drops off rapidly. But in the testing I did with the hand wheel, by manually pulling on that with a scale and measuring the distance from the crank to the centre, I knew I needed about 1 Newton meter. So in theory we had 2.5, drop a bit because it's now moving. Should have been enough at least to run it at low speed, so something else is going on. So in terms of power supply, I did run it at 30 volts, that wasn't any better, and then I ran it at 32 and it slightly better, but still nowhere near enough. Now so far this project's cost me very little. I had the power supply, the driver, step-in motor, the Arduino, the electronics. I had this already. I think I bought the keypad, but only about £5. Had all the buttons. This is spare aluminium, spare wood. You know, basically everything I had in the shop already, in my bits and pieces box. This is what we used. The only thing I really spent is some material just to make the adapter plate, but I was always going to have to do that. And then the ball screw was at the back of the machine. I've shortened that, machined it and put it in here. So the idea of this was to say, you know, with everything I've got, without spending very much money, what could I do? But the answer is, this is never really going to do everything I wanted to do, so we need to think again. So basically I think we've got two options. One is to get this basically working just so it lifts the knee up and down. So I can do continuous running at different speeds and it'd be no extra effort, just to have incremental as well, so just steps, so I can just push the button and get it to move every 0.1 mil or 1 mil, whatever. But no drilling, no can cycles with this system. It's clearly never going to be up to that. So that's option one. Option two is go all in, fit an AC servo to this with its own power supply, a braked one, and then I'd have to find a way to produce a lot more pulses a lot faster than the Arduino. That's never going to keep up. You know, and we're talking £200 to £300 for the motor and driver, and then whatever this pulse generation system's going to be. That is quite a lot just to get that auto drilling. So I think what I'm going to do is go the cheaper route, get it all working, and see if I really miss those functions, you know, that auto drill. It was really an opportunity rather than a need. So I think that's the route we're going to go. Okay, let's talk a little bit about my CNC machine. So this is the fourth one I've ever built, if you don't count all the iterations on each one. So this is the fourth major redesign, and it's got raised sides, and then as you can see we've got a moving gantry with two rails, so one each side for the Y, as you can see there. So there's a rail either side, ball screw either side, and then the Z is a box in box. So this whole assembly moves backwards and forwards for the Y, and then the Z axis moves inside there. So it's also driven by two stepper motors, so there's two, one on each side, driving a ball screw that moves the whole Z assembly up and down, and that's because the Z axis and the spindle is a huge block, so it's on a 4-rail system. Now each of those motors is 3 Newton meters, so you've got quite a bit of torque each side, moving a 1605 ball screw, so quite a fine pitch as well. And then they're each driven by this custom control box, so down the bottom there you've got the stepper drivers. So these run I think about 80 volts maximum. Now in the day these were pretty good units. I mean they're analog ones, so you go digital these days, but you know, in their day they were very good units and I've had great service out of them. Point is though, we're running at about 80 volts max on there. Well, they're capable of running 80 volts, and then the power supply up there, which is also custom made, that runs at 72 volts. So we've got 72 volts running each of these drivers, and then we're running two 3 Newton meter steppers off that to lift that Z axis. So I think rather than using all this stuff I already had lying around in my boxes, I need to start spending some money. But before we get into that, I think we need to address some of the mechanical items down here to give the whole system the best chance of lifting. So in terms of this pulley assembly here, it sits on this axial bearing here, and then inside the housing below there are two radial bearings. Now before I press the whole thing together, The lower radial bearing you could spin with your fingers, you could flick it and it would spin and keep moving. The top one, as soon as you flicked it and let go, it would stop, and it was like the inner race, I think, was rubbing ever so slightly on the bottom of the housing that I'd pressed it into. I thought I'd machined enough for a relief, but it's clearly dragging slightly, so that's really not helping things. That's the first thing. Now the second thing is the ball screw itself. Now you might have seen in the last video when this wasn't fully bolted down here, but it was bolted to the table, that when it was rotating it was slightly oscillating the base down here like that, which basically means the ball screw's bent. Now this is a generic one I bought from China quite a few years ago, and in my experience, because I've had quite a few of them, they all arrive bent to some degree or other. Some sellers are better than others, and if they're really bad you need to go and get them straightened. Now I straightened one on my CNC machine and the other one wasn't too bad, so I left it. The reason for that is, although these are hard on the outside, they have got a little bit of flexibility to account for a little bit of misalignment. But you know, you're not doing yourself any favours if this is not as straight as it possibly can be. Now I haven't got a hydraulic press in the workshop. I've got an arbor press which is only 2 tons. I might be able to straighten that up, I don't know, but we can certainly have a look at the bearing down here. And then the other thing is, this is running off a 24 tooth pulley. Maybe I need to sacrifice some speed, so I've ordered a lower pulley. I think I had a look at a 16 and maybe a 12, just give me some options. Of course it will limit my top speed, but you know, these are the mechanical things that I think I can have a look at before I start throwing loads of money at this. So I think what I'm going to do next is take the complete drive system out, strip it down and remove as much parasitic drag as I can to give myself the best chance of lifting. I think I'll leave the table on and I'll just leave it propped up with a big piece of metal or wood or something like that, because that's a bit awkward to get on and off. And let's see what we can find there, see if we can make that better. Okay, I've got the knee locked up on all that cribbing there. I've even put, just for good measure, a bit of 30mm plate in there as well, so hopefully that's not going anywhere. And then we can wind this back out and take that out. So in terms of the drive assembly, the ball screw, that spins nice and freely as it should. Yeah, no problem there. But you'll see the pulley, if I just flick it round, it's hard to tell on camera I guess, but it's not really free spinning. In fact, I could probably work out how much force you needed to apply. We'll get this out in a minute and I'll push the inner out. So this race here is fine, but it's the other race that's pressed into this bore. And although I did machine a bit of relief, I think it's rubbing, and that's not really helping things. In fact, we'll just measure the force there, take it apart, make the modifications and come back and measure the force again and see how they compare. Okay, here we go. Somewhere there, 0.5. I probably went a bit far. So 0.5, so there's 5 newtons at that distance, so I'll work the torque, and that value is here. So we can do something better than that, I think. Yeah, let's strip that down and make that better. So in terms of that, oh yeah, so that's no problem. Obviously when it's loaded, I can't really simulate that well, but yeah, that's fine. So that bit's okay. How about the housing? So this, I don't know if you remember from a previous video, but there's 2 races and then there's a little space in the middle, sort of standard practice really. So that bottom one, oh yeah, I can easily turn that. Wouldn't say it wouldn't spin, but yeah, no problem at all. Top one, oh, tell you what I'll do. Let's put a little blue mark. So the lower one, yeah, easy, just as it should be. And that one, Nope. Oh wow, that is, yeah, it's moving, but it's tight. So my suspicion, although it does look clear, it should have been clear, but I think it's very, very close. I think it's just catching on that edge, not much. Yeah, just about get my nail in there. So, decisions. I could try and press this out, but it's very tight. And I might damage something doing it. But at least I could get this back in the lathe, centre it, and actually just put a generous chamfer on that corner. That should relieve it, or just take the bore. I don't want to take the bore out too much because it's what this race sits on, so you're taking away area, but you know, a little bit won't hurt, I'm sure. Or out on the forge yaw and spin the whole thing round. Don't fancy that. I think it's too big, it probably wouldn't clear. Put it on the CNC machine, centre it, and machine a hole, but then I'm leaving the bearings in. So I'm going to get a lot of swarf in them. Let me think about that for a minute. Okay, to press the bearing out, I made up a custom tool and then combine it with some other bits and pieces I had in my scrap box, and managed to get enough bits and pieces together so I could press the bearings out. So the low one came out first, then we got the spacer. Then I had to reset it to get it back in position again, and then press the upper bearing out. So I think you've just seen me strip this down, and then I cut this away here and relieved it, reassembled it, and it was well clear, but it was clearly dragging quite a lot. So I've stripped it back down again, and I've had a couple of iterations, and basically what it is, this bore here is not completely parallel. It's ever so slightly tapered. There's not much in it, but it's slightly wider at this side compared to there. And what that means is, just get the bearing. These are very thin wall bearing, and you have to be very careful on the spec, on the preload you put on here when you press them in. So the one at this end was a light press fit, and it would spin okay, but as soon as it got towards the other end, it was too much preload and it's causing it to bind. So I've just been lightly linishing out that and trying to feel and get that back to parallel. It's not much, it's a tiny amount, but these don't need much to cause that kind of compressive load on there and get them to bind up a bit. So I've walked this back out. I think that's very parallel now, and we should be able to press these back in, and hopefully it'll work really well. So let me get that sorted out, put it back together, and then we'll bring you back. Okay, well, after a lot of back and forth, a lot of linishing of that last part of the bore, just try and get it parallel, just managed to press that in nice and easy. It felt good as it was going in, and as you can see, it spins really very freely now. It's also clear of that edge, although now I'm not so sure that was really causing the problem. I think it was the bore was slightly tapered and it's compressing it, so that's good. So let's get the rest of this back together. I don't know if it'll even measure now, but we'll try it on the pull scale test, but to be honest, that's nice and free now. Alright, progress. I think it's not. No. Oh well. Good. Alright, well, that's the bearing sorted out. I think next we need to have a look at the ball screw and just see how straight it is. I don't know if I'm going to have the ability to straighten it. I've only got the 2-ton manual arbor press. But yeah, let's have a look at that next and see how much the run out is. Yeah, we've got the ball nut removed from the ball screw, so we'll just see how flat it is. Now, the flattest thing I've got in the shop is this surface plate. It was actually an old fire surround, so kind of granite material. It's the flattest thing I've got, so it's not certified to be flat, but I trust it to within 0.05 at least, probably even lower than that, to be honest. You know, if you get a ground, a nice true ground straight edge on it, you can't see any light under it. So best thing we got, and it's certainly going to be accurate enough to see, you know, where the bend is in this or what's going on. So I think the first thing we'll do, we'll just roll it on here and see what we've got. You might be able to see where. So that looks okay. And then Right, so if I roll it, there. Don't know if you can see that on camera, that's lifting up. And then it looks okay for quite a bit of the rest of it. Just spin it on the spot. It lifts. It's okay. Oh, maybe there's a little bit just here. Okay. And then lifts. So, what's going on? Oh, okay. That bit there that I've turned on the lathe, I think is raised. So if we just spin that on the spot. There, look. So that's lifting it and bringing it back down. Tell you what, let's just turn it round. We'll hang it off the edge and see what the rest of it's like. Right, so I've got that burr off the edge there. Just spin it on the spot. That looks okay. It looks alright. It's nothing excessive. Very small amount. I don't think I'm going to be able to bend that out. It's so tiny. Just see it. Obviously I'm only looking on the crowns here. What matters is the grind down to the valley. That's where the balls run. I haven't got an easy way to measure that. Do you know what? I don't think that was the cause. Could be the ball nut, I suppose, or the concentricity of the ball nut in the housing. Maybe that bearing that was bound up was not helping. Alright, well I can dress that burr back. I mean, not that's going to matter because it's never going to ride up that high, but that looks okay. I'm not going to touch that. Okay, so I've got the main mounting plate set up there. It's blocked under there, clamped in place. That's because the bottom of the housing sticks out the bottom, so I've had to lift it up a bit. So that's nice and secure, and then we'll try and get our DTI into the bore. Give us a rough idea anyway. Okay. Now we're only running on the inner bit of the pulley bore, and then it was pressed onto that shaft and then into the bearings, so it's not a reference surface that's used, but it might give us a bit of an idea. It's about 0.05, 0.06, isn't it really, plus or minus, or maybe a bit more, 0.05, 6, 7, 8. Maybe I'll put it back together and just see what we got. Okay, I've got everything wired up again and everything, well, it's loosely bolted. I haven't fully tightened these so it can find its own position. It's bolted on there, and yeah, we found a new problem. So at the moment it's resting on that piece of wood, so if I just manually lift this up like that, already I can feel that's an awful lot easier than it was before. So it was mostly that bearing. It's okay, we've lifted it up. I don't know if you can see that on camera. Anyway, it's clear, about 5mm clear, but as soon as I let go, it wants to back drive. So it didn't do that at all before, so we've obviously released a lot of the drag that was in there, in that bearing. So next thing to check is if when it's switched on with the holding torque, does it stay in position? And then, yeah, we're going to have a bit of a think about this one. Anyway, let's switch it on with the 30 volts and the 1.8 Newton meter stepper and see if it'll lift it, I guess, as for one, and will it back drive. Right, switch on. I don't want to go up too far, but let's see if it will lift. Yep. Oh, it's holding. Alright, let's get rid of some of this. Okay, let's try going down. A bit faster. Also, I don't know if you've noticed, but it is quite loose on these, and it's not moving about, so I guess, yeah, looks nice and smooth. I've left a little bit of the wood in here because I'm going to be working in there, just tightening those up. Let's put the clamp back on. Alright, let's go down a bit more. Looks good. I know these don't show up very well on camera, but that's 85 arbitrary units. Now, when I didn't have the motor connected to anything, no load at all, I could get to around 96 to 100 on there. That was the stall out speed. So we're at 85. Let's go up. That's fine. Well, let's go all the way. Oh, 96. It's maximum. Oh. That didn't sound very happy. Alright, yeah, about 80, 84, 88. Okay, that's your maximum. And interestingly, it clearly wants to back drive, so if I'm at, let's go to 90 and I'm going to press up, it's actually trying to go up, and because it's stalling, it's actually going down. Alright, well, it's correct in that let's put that back down to, let's say 80, let's go to 80, go up again. Ah, yeah. I think while we're here, we'll just lock these off. See if that's still okay. Yeah. And down. Alright, so I think we've actually got something that works. Hands up. And down. Okay, so I think the maximum we got was about 85 on there. Alright, progress. So we're still left with the problem of back driving, so if I switch the power off on that, so it's no longer holding that on the torque, it'll drop down. Now luckily it'll only go about 5 mil before it hits that piece of wood. So let's just turn the power off. And watch it drop. Right, here we go. I thought I was going to keep going and smash through the wood then. No, looks okay. Alright, so we've got that problem next. Now there is an easy way to solve this, and I can already feel my wallet running for the hills. Yeah, AC motor with a brake on it. This would sort that right out. It'd also allow me to, lift with a lot more torque. But then you're talking, I don't know, £300–400 to get that working, including some kind of pulse system as well. Well, while we think about that little puzzle, this was the 30-volt unit, and the 48-volt unit's just arrived. So I guess we could try that and just see how much extra lifting ability we got. So I think we were at 82, 83 units on there, somewhere around there. Let's see if we can do a bit better. Okay, let's go up. Sounds smooth. Interesting, there's fans come on there. Okay, that's 82, let's go a bit faster. Let's go to 90. No. 86. 87. No. Okay. Yeah. Didn't really help. Tiny amount, maybe another 1% or one arbitrary unit on there. Not a lot really. So, I mean, there might be, I might have knocked the current limit down here, but it's really a voltage driven thing anyway. Probably the next thing is a limitation of that as being 1.8 newton meters. So let's just back that down to safe speed, 80. I should be able to go up and down. Yeah, it'd be nice to go a bit faster than that really, but it's something. And it is working. It's lifting. Alright. Okay, I think we're going to call the video there. I hope you've enjoyed watching so far. It does prove out that the calculations were correct, and there was enough torque in this to lift this up and down. It was just that bearing was preloaded too much, so I'm glad we sorted that out. Now, I've had another idea as well, which is rather than go the AC servo with brake, which is obviously going to cost a lot of money, I've just ordered a fairly cheap part, which I think, if my calculations are correct, should solve two problems. One, we'll be able to lift a lot faster, and two, it shouldn't backdrive when the power's off. So if you're interested in following along in this series and see how that turns out, feel free to subscribe. If you want to be notified when I upload another video, click that bell in the top corner. If you've got any thoughts, comments, feel free to leave those down below. And with that, thank you for watching, and see you next time.